Types of muscle fibers: slow oxidative, fast oxidative glycolytic, and fast glycolytic. Slow oxidative muscle fibers are used in endurance events, for example, a marathon. They have many characteristics that help for this type of event. For example, the fiber diameter is much smaller than the other two types, as the rate of contractions don't need to happen as frequently because it's not an explosive event. As well as this, the fibers per neuron is very few, 10 to 18, and it's an aerobic system, which means it has a very high density network of capillaries and myoglobin count, which also means more oxygen can be transported around the body to give it its bright red color. Also, it has a high mitochondria count, which means the aerobic respiration works at a quicker rate than fast oxidative glycolytic fibers because the mitochondria is used as energy, and it has a low glycogen and PC store as it doesn't need an immediate source of energy. But it does have a high triglyceride store and high amount of aerobic enzymes which help aerobic respiration to happen. The contraction rate is 3 times longer after stimulation, but this means that it is highly resistant to fatigue because of its rich oxygen supply. And these fibers provide energy submaximally. Fast oxidative glycolytic fibers are used in medium length events, for example, 400 to 800 meter races. Fog fibers have medium sized diameter, fiber per neuron, capillary density, glycolytic capacity, oxidative capacity, myoglobin content, mitochondria content, and aerobic enzyme content, which means it is the fiber which people generally have the most of. Similar to slow oxidative fibers, it has a red color because it has a dense network of capillaries and does work aerobically too, which means that it is less resistant to fatigue, but not as much than slow oxidative fibers. These fibers do, however, have a high glycogen store and a high PC store, which means its contraction speed is faster than slow oxidative fibers but slower than fast glycolytic fibers. Fast glycolytic fibers are used in short distance events, for example, hurdle jumping and 100-meter sprint. This is because they have a large fiber diameter, which means there are many densely packed myofibrils, which means muscle contraction is faster. For example, it is 0.01 speed rate, which also reduces further if there are more stimulation. Now, these fibers have also low stores of the characteristics that are required for aerobic respiration, which is because it works anaerobically, and this means that it has a lactic energy system that causes our muscles to fatigue, and this therefore means that it isn't very fatigue resistant. However, this fiber has a high PC and glycogen stores, which helps to produce the immediate energy that is required for explosive actions. These fibers are also white in color due to its lack of myoglobin and fewer amount of capillary networks. Also, these fibers provide maximal energy. Slow oxidative fibers are recruited first as they are needed throughout the whole activity. Then secondly, fast oxidative glycolytic fibers are recruited, and finally fast glycolytic muscle fibers are recruited. This is because they are needed in the last 5 to 20 seconds of muscle contraction when maximal effort is required.